Hey, this is Brock Lemires, and in this video, we're going to walk through how to install the Quartus Prime Lite software, including ModelSim and the device drivers for the DE10 Lite FPGA board. Okay, before we do this, let's just talk about roughly what these are so we kind of know what tool does what. So beginning with ModelSim, ModelSim is a logic simulation tool. So all it does is take inputs, drive it into your system, and then produce waveforms or a transcript of the outputs. So it's only used for simulation. So you're going to be designing stuff in VHDL, you'll compile it, you'll take a test bench, drive stimulus into it, and then you'll observe the results using waveforms. And so ModelSim is the tool that does simulation. Next is Quartus Prime. So Quartus Prime is a synthesis tool, also called an implementation tool. But what this tool does is it takes your VHDL, once you verify that it works in ModelSim and you're ready to actually put it onto a device, you run the Quartus Prime software and it takes your VHDL and it actually synthesizes it into gates. So it actually builds the logic circuits that implements your VHDL. And then the implementation part of it is it takes those basic gates and it maps it onto the hardware of the device that you're targeting. And in this situation for our courses, we are targeting a Intel MAX10 FPGA. And so down here is the FPGA board that we're going to use. DE10 Lite is what it's called, and on it is a MAX10 FPGA, this large chip. And this is an FPGA, you'll learn about what this is, but it's basically a big array of programmable gates. And when you implement your design using Quartus, it actually maps your final logic gates into the gates of the FPGA, and it creates the configuration file that is downloaded onto this board that then allows you to prototype your design. So when we grab Quartus Prime Lite, that does a synthesis. We also have to grab the device files for this particular FPGA so that it knows how to map your circuit onto the devices that are available. Okay, so let's go download the software. So to begin with, this FPGA comes from Intel, formerly Altera. Altera was the company that created these FPGAs. They've been around for 20, 30 years. Intel recently purchased them. So you will see some of the FPGAs are still marked as Altera, but we get our software from Intel. Okay. All right. So let's see what we do. Let's go to intel.com. And what you're going to do is once you get here, you're going to come up into the product section and you're going to click on it and it'll bring this drop down menu down. Come over here to FPGAs and programmable devices. Come down here and you're going to see Intel Quartus Prime design software. That's where we want to go. Okay, so it brings all this stuff up and you're like, okay, this is great. You can read about it. Come here to the downloads tab. And this is where you're going to see what software is available to you. There's different versions, Pro, Standard, and Lite. We want the Lite edition. Lite is free for small designs, and that's what we use in the academic environment. Once you go to Standard and Pro, it gives you more features and also allows you to have larger and larger devices, but we will never do anything large enough to need that. We want the free academic version, so we want the Lite version. So we're going to do this for Windows, and then here is kind of the big thing. You are going to download individual files. So when you see up here, it's saying, what version do you want? Usually you want the latest version, but not in this situation for ModelSim. So what we want to do is the following. I'm going to download all files individually. And so when I scroll down here, you can say, oh, I want all the things downloaded. I want everything included. We do not want to do that. What we want to do is say individual files. Okay. And then when you come up here, when we choose the latest version of that, that's fine for Quartus. So when I come down here, I'm going to say, here's Quartus Prime, includes this processor thing. Go ahead and download that. So I'm going to click download on that and it's going to start. It's going to ask me, do you really want to do it? And it's like, yes, I really want to do that. And it starts downloading. Now these are big files. So Quartus alone is 1.6 gigs. And so what I'm going to do is I'm going to let this download and then I'll stop the video and then I'll come back once it's done so that we don't have to sit here and watch this thing download. Okay, so Quartus is now downloaded. That took me about a minute to download that. What I'm going to do is I'm going to go ahead and just put that right on the desktop, and we'll see why I do that in a second. So it's going to copy that baby over to the desktop, and there it goes. So now I got my Quartus Lite .exe right there, okay? All right, so now I'm gonna go get the next piece of software. So I'm gonna go back, and this time I wanna go get ModelSim, okay? So what I wanna do is ModelSim only exists up to 2020 within Intel's system. What Intel ended up doing is once they bought Altera, they changed ModelSim to be this thing called Questa, and it requires a license, and we don't want anything to do with that. We want to use ModelSim. So we want to that's why we have to do these files individually. You want to go up here to version, and you want to go all the way back to 2020. So this is the 20.1.1. And now when you come down here to individual files, you'll see that Questa's gone, and now you have ModelSim here. Now, don't worry about ModelSim being out of date. ModelSim hasn't changed in almost 30 years. It's just that Intel put a wrapper around it and is trying to make their own version of it. But unfortunately, it requires a license, and we don't even want anything to do with that. We want ModelSim. So I've gone, big thing here is 20.1.1, and that's what allows the individual files to show ModelSim. So now let me click on that, and this now is also a 1.2 gig. So this is going to take a second. So let's let this download. Okay, so ModelSim's now done. That took about 45 seconds. I'm going to go ahead and drag that over to the desktop also. So it's in the same folder as Quartus and ModelSim, and we'll see why that is. Okay, so now let's go get the device drivers. So I'm going to go back. Now what I want to do is individual files again. This time I want to go back and get the latest version. And this is, I'm trying to get the the MAX10 FPGA drivers, and you always want the latest drivers. So I go back to 22.1.1, and now I come down here and I go individual files, and I'm going to scroll down, and I'll come down to this section called devices. This lists all the files, all the device support files for all the FPGAs that Intel supports. Now there's a lot of them, and they're not small. They're 500 megs, 250 megs. So you don't want to like download all of them because it's just unnecessary. You only want to download the devices that you're using. We're only going to use one device, which is the MAX10 FPGA. So you come down here, and this one's 300 megabytes. So you go ahead and click download on the MAX10 FPGA, and you say, okay, accept. And so it's going to download. And then when it gets done, I want to put that also on the desktop. Now, here's the reason that I'm doing that. When you go to install, what you do is you double click on the Quartus executable. If you have other files in the same directory, such as ModelSim and the device drivers, it will automatically grab those and install them. So we're set to go right now, but that's why it's so important to have these in the same file, or in the same folder. I put them in the desktop because I'm going to delete them as soon as it's installed. But if you wanted to put it in some drive on your hard drive, or some folder on your hard drive, that's fine too. Just make sure that they're all there. Okay, so before we start, Quartus Lite latest version, ModelSim 2020 version, and then MAX10 latest version. Okay, so they're all three there, and I'm going to double click on Quartus Lite, and it is going to install. It's going to attempt to install everything. For sure, it's going to bring in the MAX10 drivers. Okay, so let's now watch this thing install. I'll wait until the screen comes up, and then we'll start it, because this install actually takes quite a while to do, so we don't want to sit here and record the entire thing. Okay, so while I was waiting for it to start, it flashed the Intel screen, and it's starting the install. Okay, so here we are. It's just standard install. You just hit next, accept the license, whatever. Let it go into its own spot. Don't tell it where to go. Everything works better if you just let this thing sit on your C drive with no spaces and anything. And so go ahead and hit next, and it's going to ask you, what do you want to install? It's doing Quartus Prime Lite and the MAX10, so it didn't grab ModelSim, so we'll have to do that separately. Not a big deal. So let's go ahead and say install, and now what you do is you basically just wait. So I'll pause the video and let that go. Okay, so the Quartus Prime install has completed, or at least sort of completed. That took a half an hour. So this is a big program. So when it's ready to go, you want to finish, launch USB Blaster 2 driver, yes, create shortcut, whatever. Launch Quartus Prime software. We don't need to do that, but let's go ahead and finish this up, because what we'll do is we'll test everything here once everything's gone. So it's like, okay. Device driver. Now this is an interesting step, because you're going to do it. It says we're successfully installed. Life is good. So one of the problems with this install is that it installs the drivers, meaning it copies it in there and everything's great. But when you plug the board in for the first time, the drivers don't automatically work. So there's another step that you have to do to actually get the Quartus tool to download the bits. And so that's where most people get tripped up, but I'll show you how to do that. Okay, so ModelSim didn't install though, so let's go ahead and fire that one off. So go ahead and double click on ModelSim. So it's gonna take a second to load. And so now the ModelSim is ready to install. It took like 2 minutes for this to pop up, by the way. So if it's sitting there for a long time between when you double click on ModelSim and when this comes up, don't worry and resist the temptation to try to double click again, because what'll happen is you'll launch like 2 or 3 of these or 10 or whatever. So anyway, ModelSim comes up after a couple minutes. It's like, which one do you use? Big decision time. Do not do the licenses required. Make sure to get the starter edition. That is free and no license. So you go ahead, boom, 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 install it. Please leave it where it is. Don't put any spaces. Don't put it anywhere else. Just leave it as Intel FPGA and you're ready to roll. And this again is a large program. So let's let this install. And that now is done. And that took 10 minutes, so not that bad. So go ahead and we'll go finish. And now everything's installed. But at this point, let's test it. So the first thing I'm going to do is let's run a simulation in ModelSim and make sure that it works. If you don't know what I'm doing, that's fine. This is just kind of a preview of what you will be doing in these courses. So I encourage you to type along. Even if you just type in what I do and do the actions, it'll help with understanding it later. And you can always look back on this video after we've covered a lot of VHDL and just as a reference of where buttons are. So for ModelSim, I'm going to create a new folder and I'm going to call it ModelSim test. And in here, I'm going to put my design files. Okay. All right. So now I'm going to launch ModelSim. So I'll go over to my start menu here and search for ModelSim. And there it is. Comes up. You see it's the Intel starter version. That's good. And here comes ModelSim. Okay. So this is what the ModelSim GUI looks like. And what I'm going to do is, the way that it works is you create a file, which is going to be your design, and we'll call it top.vhd for VHDL. And then we'll also create a test bench really quick. And let's just do an inverter and just drive in a wave and see if it inverts, okay? So what you do is you say File, New, Project, and then for your location, you browse to where your folder is going to be, and you want to work in that folder, okay? So for me, I put everything on the desktop, and it's ModelSim test, and I say select folder. And then I always name my project all capital. And then that makes it easy to find the project file. And then for default library, leave it at work. So I say, okay. And then it's going to ask you if you want to create a new file. And I'm going to say, yes, I do. And I'm going to call it top.vhd. And that'll be my system that I am going to design. And then I'm going to create another one called top_tb.vhd, and that stands for test bench. And we'll have to put the code in there to actually drive the top. So go ahead and close. And again, you don't need to know ModelSim at this point. You just install the tools, and this is what you're going to learn how to do. So I'm going to double click on top, and it's time for me to enter code. So let me zoom in so you can see this a little bit better. This is just going to be standard entry level VHDL. So I'm going to do entity top is, and then port, and then I'm going to call it, what I'm going to do here is just create an input and an output. And we'll call the input, let's just call it A, and then its mode is going to be in, and its type will be just standard bit. And then for the output, let's call it F, and its mode will be out, and it'll also be of type bit. Okay. All right. So then I close that up. I say end entity, and what an entity is basically defining the inputs and the outputs. Okay, so we have input A, output F. All right, so now I'm going to define the architecture, which is the functionality of this, and this is where I'll tell it to be an inverter. So I'm just going to do architecture, and what I do is I always call it, the architecture has a unique name, so I'm going to call it top_arc for architecture, and then I link it to my top entity by saying of top, and notice this top matches that top, or this name matches this name, and that's what links this behavior to the entity. And I say is, and then I come down here, and I'm going to say begin, and I'm just going to 1, 2, 3. I'm simply going to go F gets assigned not A, and that's my entire program. So I'm going to do end architecture, and I'm done. Okay, so I save it. I'm going to come over here, and I'm going to right click on this and say compile selected, and it's successful. Okay, so I made an inverter. So now what I need to do is I need to create the test bench for this. So I'm going to come over here and let me zoom in a little bit. I'm zooming in by holding control and hitting the plus key. So what I'm going to do is a test bench doesn't have any ports on it. It's just basically going to be a box with no input and output where it's going to call the lower level device under test, which in this case is top. So I'm going to go entity, and then this is going to be top underscore TB, and then is, and then since there's no ports, I just say end entity, and I'm done. Okay, so now I'm gonna do architecture, and I'll call this top underscore TB underscore arc for architecture, and then of, and I link it to my top underscore TB, and I say is, come down here, and say begin, and then I'm ready to start. But before I do that, I need to declare the gut that I'm testing, which is top. So the way I do that is with a component call. So I say component top, and then I give the port map of it. And just to be safe, I'm just going to copy it from here. So I'm just going to make sure that I don't misspell anything. So I can come down here and I just do that. And I say port A, F. And what this does is it tells the test bench that it's like, we're going to use this little fella, this little entity that exists. So I say in component, and there it is. Okay, so I've declared it. And then what I need to do is declare a couple signals so that I can attach to the ports of our little device under test. And I'll drive A with a waveform, and then I'll watch F just with the waveform viewer. So let's call it A underscore TB, and then F underscore TB. And those are of type bit also. They don't have a direction because they're just wires. And now I'm ready to go. So what I'm going to come down here and do is I'm going to begin. I'm going to say .1. I'm going to instantiate this, and I'm going to say instantiate top, please. And I want to do a port map, and now I'm going to connect up A underscore TB and F underscore TB. And this is positional port mapping, meaning that the first thing I list, the first signal, will be attached to the first port name in my component. So then F is attached to that, and life is good. So I've now instantiated it, and now what I need to do is actually drive signals in here. So let's just drive a square wave. So I'm gonna do process and go over here and say begin. And then what I'm gonna do is let's just drive in some ones and zeros. So I'll say A underscore TB gets assigned a 0. And then I'm gonna do wait for 10 nanoseconds. And then I'll do that. I'll drive it to a 1. And then really, that's it. I'm done. Okay, so I'm going to do that. So it'll start at a 0, wait for 10, go to a 1, wait for 10. And then this will repeat forever when in here after I do the end process. And I am now done. So I just got to do end architecture, and I got it. So save that buddy up, and let's make sure that it compiles. So I come over here, compile selected, and life is good. So now we've got our DUT, we've got our system we designed, which is an inverter. We've got the test bench. Now let's go run a simulation and see how we do it. So I come over to library, and in here you'll find your work directory, which is where everything was compiled into. So top and top TB. I'm going to double click on the highest level, which is top TB, and that loads up a simulation of the information that was compiled from our VHDL. And you'll see up here, you'll see these object names. These are the signals that you can observe. So right click in there and say add to wave signals in region, and it'll add them to a waveform. And now what I can do is say, well, let's run this for like, I don't know, 100 nanoseconds. And I run it, and lo and behold, it's zoomed all the way out. You look down here, you got this little tiny slider. So you zoom full, and there we go. I got A coming in as a 0, comes out on F as a 1, A is a 1, F is a 0. It's an inverter. That shows me that ModelSim is installed and ModelSim is working. So now to get out of this, I'm going to come up here and I'm going to say this little icon, or excuse me, I'm going to do simulate and simulation. Are you sure you want to quit? I do. And then I'm going to close up these files, these VHDL files, and now I'm going to close my project. So I go to the project tab, right click, and say close project. We'll close. Now we're back to the base ModelSim, and I have verified that the install works. Okay, so now let's test Quartus. So what I'm going to do is create a new Quartus file. Quartus project, and I'll run my top.vhd through it, and we'll try to take it all the way to hardware. So create a new folder. I'm going to call this Quartus test. Quartus projects are all held in their own folder. And so what I'm going to do is put that right down there. And I'm going to implement an actual circuit. So the circuit I want to implement in my ModelSim was the top.vhd. So I'm going to copy that and go into Quartus, and I'm going to paste it. And so if you think about it, the test bench was only just to verify that my little design was working. So the test bench isn't something that ever goes in hardware. It's just for simulation. And so that's why I can move just the top.vhd into Quartus. Okay. All right. So I'm going to go ahead and go over to my start menu, and I go ahead and launch Quartus. And for the first time, it says, do you want to buy a license? You want to add a license? I'm like, no, I just want to run Quartus. Because we got the free version, we got the light version. Okay, so it launches, it comes up, we got this big old screen right here. Let me get it sized on there for you. And then what we're gonna do is we're gonna do the new project wizard. So what we will do is new project wizard right here. And what it's gonna ask is a bunch of different questions to set this up. And so we'll go ahead and say, next, and it's going to say where's the working directory of where you're at, and what I want to do is I want to browse to where I put my file. So I'm going to come up here. I'm on the desktop. When you do the class, you'll have better organization, but we go to the desktop, go into Quartus test, I say select folder, and what is the name of this project? I'm going to call this we'll call it something descriptive as we go, but for now let's just call it top. If you were doing a real design like a 7-segment decoder, you might put 7-segment decoder, but we'll go ahead and just say top. So I'm going to go ahead and say next, and then what I want to do is say give me an empty project, and then it's going to say do you want to add files? Okay, now this is where I want to add my file. So I click the little search thing right there, and it's looking for design files. So I'm going to come over here and I'm going to browse to where my design file is. In this situation, we did it in Quartus. A lot of the labs, you actually do it. We designed it in ModelSim. In some of these ones that you do in the class, you actually design it within Quartus and kind of test it in hardware as you go. But for this one, Quartus, we have the dot that we want. So I say top. It adds it in there. I say next. All right, now it's ready to say which device do you want. Luckily, if you come up here under the family, the only one that shows up is the MAX10, and that's because we installed the MAX10 device driver. So if I would have installed all the FPGAs, you'd have a drop down here, but this is good because we only have the MAX10. It's really good because within the MAX10 family, you have tons and tons of FPGA devices. And so it's almost overwhelming when you go through all these down at the bottom in order to try to find like which one you actually want to use. So the best way to do it is, since we know the exact FPGA that's on our board, we can actually type in you can type in letters into the filter and start narrowing it down. So uncheck this show advanced devices. That'll give you some grief. So what we want to do is type in the part number. So you go 10M, and it starts narrowing down the devices that are available. If you have this checked right here and you type 1, sometimes it'll give you some grief. But for anyway, just uncheck that and then go 10, and the part is M, and then you're gonna go 50, and notice how this list is getting smaller and smaller, and then you're gonna go to DA, and it's getting smaller and smaller, F, 484, C6, GES, and there it is, and that's your device. They've added a feature where you can actually go to the board up here and choose which eval board, and our board is actually on here. So you could have actually just gone to the board and said, I'm using this one right here, and it gives you that same FPGA because it already knows what's on there, or you can choose it this way. So once you do this, you actually don't have to do it anymore. So I'm gonna go next, and I'm pretty much, actually go back. Over here, I've created this thing right here, Life is Good. And what I want to do is under board, do not create a top level design. Okay, we already have done that. So then go ahead and say next, and then just leave all these tools the same, and then go ahead and say next. It gives you a summary. Here's the folder, project name, top level is top, my device looks good, everything's good. And I'm gonna go ahead and say finish. Quartus only trusted. Do you want to continue? Yes, I do want to continue, and I want to run this buddy all the way from start to finish. So now I have my top over here. So if I double click it, there's my entity. So my design is in here. Like I said, a lot of times in these labs, you're going to start by creating a top file and entering your code. But for what we did is we know this code works. It's an inverter. And so we're going to essentially just use this and synthesize it. So what we're going to do is we are going to go to the next step, which is synthesize. No, we want to assign the ports. So, excuse me, we want to compile it. So I'm going to come over here and I'm going to compile this thing. So let's make sure that everything's saved up. So go ahead and save project. Everything's great. And now I'm going to come over here and I'm going to say compile design. So over here is all the actions I can run. If I say double click on that, it's going to run all the tools on here. It's going to now analyze it, see what kind of circuits we're doing. It's going to look at the synthesis, create gates out of it. This one's pretty simple because it's an inverter. It's going to map it into an inverter. It's going to see if it's got room on the FPGA to actually fit it. It's going to create the programming file and do all this, create all this information for you. And it's going to crank out everything and get it to the point where it is actually logic on the FPGA. Now, we are ready essentially to start thinking about putting it onto hardware. But one of the things we have to do is we have to assign the pins on the FPGA. So right now we have A and F, but they're not connected to anything. So what I want to do is we got to connect these up to pins. So what I'm going to do is I'm going to come up here and I'm going to go to assignments and do pin planner. And it's going to bring up this thing and say, well, here's all the pins that you got. And you can make this bigger if you want. And it shows you, here's all the pins on the device. It's pretty cool. And what it did is it says, here's your input and your output. It knows this based on the VHDL. And you can then go in and you can do locations. So why don't we attach this? If I pull up the user's guide for the DE10 Lite board, I know that I have a switch on pin C12. And so what I want to do, is I want to double click on location and I can see all the different options that I have. So I'm going to scroll down and let's use switch 0. Sorry. It's on pin C10. So, and I'm getting this from the user's guide that I have off screen here. So switch 0 is going to slider switch on the board and it's going to go to pin C10. So I walk down here, pin C10. Okay. And then my output, let's put it onto an LED. So I double click on that. This is confusing sometimes. You click on these and that doesn't look like they're doing anything. You have to double click on them to get the drop down. So now let's put the output of the inverter on LED 0, which is pin A8. And I'm getting these from the user's guide. Okay. All right, so we got that. And what I can do is there's no save on this thing. So basically to save it, you just close it. And now I have to compile it again because it needs, now that it knows where these things go, you have to go back and notice that these all went yellow again. So it's like, what do you want to compile and get this going? It's like, yeah, now that you know the pin, take it all away. And that's really all we need to do. So now once we're done with this, we can plug in our FPGA and we can actually try to download it. And then we'll test it and see if the little light lights up. Okay. So let's let this run. This doesn't take very long because it's just one inverter. You might get to points where you have a large design, and this can take, depending on the size of your stuff. We have stuff in our labs that'll take hours to compile, but this is relatively simple. Since it's so quick, that's why we can actually design and test in hardware as opposed to doing everything through ModelSim first. So anyway, so now it's ready and I'm ready to start thinking about programming the device. Okay, so I've turned my camera on so you can see the FPGA board. This is the DE10 Lite board, and this has the MAX10 FPGA on it that we selected. And we're going to download our bitstream to it using the USB cable provided in the kit, and it's a USB type B connection. So I'm going to go ahead and plug this in. And you'll hear Windows go doot doot doot. And what'll happen is that this gets power from the computer over the USB connection. So the thing powers up. And you'll notice that it already has a pre-programmed FPGA design on it that just flashes the LEDs on here. But we're going to override that one using our own bitstream. Okay. So when you plug that in, you'll hear Windows recognize it and it'll attempt to go ahead and install the rest of the drivers. And the first time you do it, it'll fail. Okay. And so let me show you what you'll run into when you do this for the first time. So I'm going to come over here into Quartus and I'm going to say program device. So I open up this and what you're going to see is this thing that says no hardware. Okay. And what it's doing is the drivers are not installed correctly. Okay. And so what you have to do is you have to actually go into Windows you have to go into Device Manager in Windows and install them manually. So let's do that really quick. What I'm going to do is I'm going to go over and I'll go ahead and just type Device Manager into Windows. And you come over here, and then what you're going to do is you're going to go down to USB drivers. Okay, and you notice this USB blaster, it has this warning on it. Okay, and so it's got this problem where it didn't get installed. So this is really misleading because when you install Quartus, it acts like it installs it. Then when you plug in the board for the first time, it errors out when it installs the drivers, and then you can't find it in the programmer for the first time. So you have to go in and complete this manually. It installs the drivers in the fact that it copies it over to your computer. So it's simple though. All you do this one time is you just right click on this, and what you're going to do is say update driver. Okay, and then it's going to be, where do you want to do this? And you're going to browse on your computer, and what you're going to do is go into the install directory. So you go into C, and under C you're going to see Intel FPGA Lite. Okay, and then you're going to come down and you're going to go into, let's see here, you're going to go into the latest version of it, and then you'll go under Quartus, and then you'll come into here and go drivers, and then you'll do USB blaster. Okay, then stop. Don't select X32 or X64. Go ahead and just say okay. All right, so then it's going to be all right, and then do next, and it's going to try to install the drivers. So now it says it successfully updated your drivers, and you say close. All right, so now you've got this Altera USB blaster in here. So you can close this, come back to here, and now when you hit hardware setup, you come in here and you'll notice that this no hardware, you have the option of USB blaster. So now you choose that, and it's like, okay, that opens the port to this device that it sees down here. And what you can do is once you click on that, you can actually hit start, and it's going to try to download your design to the FPGA. And so now everything looks good on here, and I can come over here and test it. Notice that all the LEDs are dim because they're not being driven, but look at LED 0 here. If I switch the switch, look at that. It lights up the LED. And this is LED 0, this is switch 0, and I can sit here and I can flick. A 1 on the switch is a 0 on the LED, a 0 on the switch is a 1 on the LED, and we have our inverter in hardware. And this is great because now we never have to install that USB driver again. So every time that I do a project, it is automatically installed. You just plug in your cable and you're off and running. Okay, that is it. And from here on out, we can start building larger and larger VHDL designs, and we know how to simulate them in ModelSim and synthesize them in Quartus. All right, see ya.